Welcome to our electromagnetic theory course. In last class we discussed about Ampere circuit law. Okay. What is Ampere circuit law? The line integral of magnetic field intensity around a closed path is equal to the current enclosed by that path only. Okay. So from that we derived what? Del cross H equal to what? J. Now let us apply divergence on both sides. Okay, I will consider like this. From Ampere's circuit law, or else Ampere's circuit law, we have del cross H equal to J, apply divergence on both sides, apply divergence on both sides, we will get what? Del cross H on left hand side is equal to what? J. Now this one is equal to what? So here this del dot, okay, dot product del cross H means what? Here we will get a vector. That vector is perpendicular to what? This del and H. Okay, A cross B gives what? Here I will write A cross B equal to what? C. Okay, let us say A cross B equal to C. That C is perpendicular to both A and B. Here also same thing. Del cross H gives a vector. That vector is perpendicular to both del and H, or else perpendicular to this plane del and H plane. So means what? This one, let us say it is some, okay, on left hand side I have, okay, on right hand side it should be del dot J. Okay, this del cross H gives some vector A. Okay, this vector A should be perpendicular to what? Both del and H. Means what? The dot product of this del and this one means here I have some vector A. Okay, the angle between this, as A is perpendicular to both del and H, means the angle between A and del is what? 90 degrees. As it is dot product means what? That is A bar dot B bar, let us take. So that is mod A mod B into cos theta. What is theta? Theta is the angle between A and B. Here also same thing. The angle between this vector A and del is 90 degrees, means cos 90 is 0. So it should be 0. So this is what? Del dot J equal to 0. But from continuity equation, we have del dot J is equal to minus dou rho V by dou T. Del dot J equal to minus dou rho V by dou T. Okay, but here it says what? Del dot J is equal to 0. Here del dot J we got this one. Okay, so let us take this as equation 1, this is equation 2, this is equation 3. If you observe this equation 2 and equation 3, these two equations are incompatible. That is, equation 2 and equation 3 are incompatible. Equation 2 and equation 3 are incompatible. Why this one is happening? Because there is a inconsistency or else invalidity in this equation 1. Okay, so that's why we need to modify this equation 1. Means what? This is the Ampere's circuit law. So that's why there exists inconsistency in that Ampere circuit law. We need to modify that Ampere circuit law, or else we need to go for what? Modified Ampere's circuit law. This one, divergence of curl of any vector. We can call this divergence as D. Okay, curl means C, DC. Okay, the frequency of the DC signal is 0. We can remember this vector identity. Divergence of curl of any vector is 0. Okay, this is always true. Okay, so that's why as it is true, and we know that del dot J is equal to minus dou rho V by dou T, that is continuity equation. From that continuity equation, this del dot J is non-zero quantity. But according to this one, that is, if I apply divergence to this vector, divergence to this del cross H on both sides, on left hand side I will get what? Del dot del cross H equal to 0, but del dot J should be non-zero. So that's why we need to modify this equation 1. What is this equation 1? How we can get this equation 1? We got this equation 1 from Ampere's circuital law. So that's why we need to modify that Ampere's circuit law. Okay, basically here if I apply divergence on both sides, I will get divergence of curl of any vector as 0, but on right hand side I have del dot J, but we came to know that del dot J is a non-zero quantity. Del dot J equal to minus dou rho v by dou t, it is nothing but what? A continuity equation. It is nothing but what? Continuity equation. Continuity equation. Now we will discuss about that continuity equation. Okay, please treat this one as the part 1 of this video. So for the inconsistency of Ampere's circuit law, okay, this is part 1. In part 2 we will discuss about, basically we didn't know about this del dot J is equal to, okay, actually I wrote del dot J equal to minus dou rho v by dou t. We need to prove this del dot J equal to minus dou rho v by dou t. Okay, we can prove that del dot J equal to minus dou rho v by dou t by using this continuity equation. Now we will discuss about continuity equation. Later we will enter into, okay, modification of this Ampere's circuit law. Why we need to modify Ampere's circuit law? Basically if I apply divergence on both sides, okay, on left hand side I need to get this one as 0, on right hand side what it is? Del dot J equal to, okay, on right hand side I have del dot J, but del dot J equal to minus dou rho v by dou t. So that's why I need to modify this equation 1. In part 3 of that video, part 1 is this one, part 2 is the continuity equation, because here we stopped, okay, we don't know about, we don't have any idea about this one. So that's why we need to move continuity equation. That is part 2 of this video. And next part 3 is nothing but what? Part 3 is what? Modification of Ampere's circuit law. Thank you. We will move to part 2, that is continuity equation.